Similarly means in same way, singing a song, discussions, etc. will also be not considered as work in terms of science. Okay, so singing a song, discussion, and what is that thinking, all these are not the work according to the science. For example, if you hold up a chair for 10 minutes, are you doing any work? We are holding only, but we are not changing the place of the chair, so it is not a work. From your tiredness, you might say that you have worked a lot, but according to the definition of physical work, you have not done any work on the chair while you holding it at one position. So holding the chair is not a work. If you change the position of the chair from one place to the other place by using some force only, it is the work. Otherwise it is not a work. Okay, so here when we see, now this boy is pushing the stone. Is it a work? It is not work according to the science. This girl is going from down to top. It is the work. She is changing the place, na? And she is using some force also. Here this boy is using the force to push the stone, but this stone did not change the place, no displacement. That means no change of place. So it is not a work, but it is a work. Okay, so here you pushed a very large stone, but it did not move. That means it is not a work. Traveler pulls his luggage to some distance on a platform. That means a traveler, some passengers, he moved the luggage from one place to the other place. So it is a verb. Stopping a moving bicycle. Okay, so it is also a verb. You see some chairs, tables, benches, etc. in your classroom. Pick up all this one by one and raise them to a certain height. To raise which one of these, you have to do the most work, and why? Work done by a constant force. Okay, so continuously we are lifting the chairs from down to top. Work done by a constant force. Next, if we knew the amount of force applied and the displacement, we know the calculate the work done. Okay, so according to the scientific definition is what? Work done means force into displacement. Okay, so force we are denoting by capital F, displacement S. Okay, distance. Work done is W. That is why W is equal to F into S. Okay, so this is the one. Book is moved from here to here. So how much distance? S is the displacement, F is force, and work done is equal to W is equal to F into S. Okay, and the next one. And we know that SI unit of force is Newton. So SI unit means what? Okay, this is the systematic units, na? So you know the units, no? For example, liquids, water units were liter, and vegetables kilogram. These are the units, na? So like that only for the work done. What is the units? For the first force is what is the unit? Newton, N. And the displacement, for the displacement, what is the unit? Changing the place, na? Distance from one place to the other place, na? So it is the meter, M. For the force, what is the unit? Newton. That means capital N. So the unit of work done will be Newton into meter. So capital N, M. And it is also known as a joules. Underline these two lines. Okay, joules. So if we put F, force, 1 Newton force, and by applying a 1 Newton force, we moved the book at 1 meter, displacement has taken place. So work done. So 1 Newton, 1 meter. So 1 Newton into 1 meter, 1 Newton meter, or 1 joule. So W is equal to, we can say 1 Newton meter work done. Otherwise we can say 1 joule. Okay, this is the SI unit. So SI unit for the work done is what? Newton meter or joules. Okay, so these are the SI units. Hence 1 joule is what? Quantity of work which is done. When 1 Newton force is applied, 1 meter displacement has taken place. Okay. So this is the one. So here are some calculations are there which you understand very easily. Okay. We will see those calculations. Very easy lesson. Okay. A girl, okay, so here when we see a girl applies a force 4.F N Newton on a book kept on a table. This book is moved to 30 centimeter in the direction of applied force. So calculate the work done. Okay, that is means W is equal to F into S. F is how much? 4.5 Newton. Displacement S is how much? 30 meters. So 4.5 into now it is given 30 centimeters, na? But displacement displacement SI unit what it is given? Meter. So that is why first we change the centimeter into meter. So 100 meters are equal to 1 centimeter. That is why 30 by 100. So it comes 0.3 meter. So 4.5 N into 0.3. So work done is 1.35 joules. So next one. A person picks up an object mass 20 kilogram to a height 3 meter. Calculate the work done. Okay. So the mass means weight. Weight of an object is what? 20 kilogram. He lifted up. How many meter? 3 meter height. So meter, mass of an object is how? 20 kilogram. Okay, displacement is how much? Displacement is the 3 meter. Okay, displacement is 3 meter. So afterwards how the work done? We will see 3 meter. So here we take force. F is equal to mg. That means mass into g means gravitational acceleration. Last lesson we see na. G means what? Gravitational acceleration. Because of the gravitational force, the thrown ball can come down. Okay. So here force is equal to, we take mg. M is the mass, g is the gravitational force. Okay. So 20 kilogram. Gravitational force always what is the value? Last lesson we saw 9.8 meters per second square. So 20 kilogram, this much. So force is what? Unit Newton. So how much force is used now to lift up the 20 kilogram? 196. So 196 into 3 meters. So this is the joules used. Okay. So a box filled with books placed near a wall. Even if several efforts by you, then box does not move. Calculate the work done according to the equation W is equal to Fs. So here is the box is here. We are applying a force but not moving. It is a work done? No, it is not a work done. Okay. So displacement is not there. Absence of any force. Okay.